How are the plans coming along for collecting samples from the animals?
Great. We're going to sample from treatments 1 through 3 on Monday, 4 through 6 on Tuesday, and 7 through 9 on Wednesday.
Whoa, you shouldn't do that. You'll confound our treatments with batch effects.
What are batch effects?
Batch effects can occur when subsets of a data set are collected in a way that systematically differs from the ways in which other subsets of the data are collected. Batches are sometimes referred to as blocks or waves or groups.
What do you mean by systematic differences?
These are innate differences between batches that may occur in time, place, procedures, calibration of instruments, or persons doing the collection, among others. Think of examples like starting blocks of animals on separate weeks, assaying samples in different runs, or, in this case, euthanizing only some of the animals at a time.
But we can't euthanize all of the animals on one day, though. I don't see how we can avoid batches.
Batches aren't themselves necessarily a problem and are sometimes unavoidable, like in our case, but it takes planning to make sure they are organized correctly. Batch effects can cause confounding if the treatments are in some way related to the batches. In the extreme, this can happen if all of one treatment was processed in one batch and all of a different treatment was processed in another batch.
So we're less worried about the batches themselves and more worried about confounding batches with treatment?
Right. Think of the day you collect samples as a form of a batch. If we euthanize the animals in the way you suggested, then treatments 1 through 3 will only be represented in one batch. 4 through 6 would only be represented in another batch, and 7 through 9 in yet another batch.
I see how that would cause treatments to be confounded with day, but is the difference in one day really going to make that big of a difference?
We never know. It might, so why risk it? Let's say you collect all of the planned samples on one day, and then the water recirculator for the fish breaks that night. The next day, you still collect the planned samples, but now treatments 1 through 3 were collected with a working recirculator, and treatments 4 through 6 were not. Can you really feel confident that your results, particularly acutely sensitive measurements like physiological markers, are only due to the differences in treatment?
Okay, I can see how something that extreme could cause confounding, but that's a pretty unlikely scenario.
But not impossible. What if something more subtle happens that we don't notice? Like if someone is tired on a day and gets a little sloppy with the procedures. Could that make a difference?
I suppose it could. So what do we do?
We can avoid confounding treatment effects with batch effects by balancing treatments within batches. This helps ensure that we don't create an association between the time, place, or measurement method and our outcomes of interest.
So, in this case, euthanizing animals from each treatment group whenever we have a euthanization day?
Right. If we can only process 36 fish per day and we have 9 treatment groups, we could randomly sample 4 animals from each treatment group.
That sounds easy enough, but you also mentioned batches while running assays. How could that be a problem?
Well, as an example, we are planning on measuring glucose with a kit. Ideally, each run of the assay would be perfectly reproducible, but there is always some technical variability. Each batch will be a little different from other batches, and the samples within a batch will share those differences. If you assay only one treatment group at a time, you will confound batches with measurements.
I see. So we will determine appropriate batches within assays, too.
Great. Make sure to record which batch each sample comes from. Although balancing treatments within batches gives us valid between-group estimates, we may be able to account for variability from batches in the statistical analysis, which could give us more statistical power.
How so?
If each batch is a little different, then there is some variability in the data that is caused by the batches. In some cases, the variability from batch could be just as big or bigger than the treatment effects. But because we balanced treatment groups across batches, that variability is balanced across treatments as well. Then we can account for batches in our statistical model.
Cool. But I just thought of one more thing. What happens when we can't get one of each treatment in a batch? We have some assays where we can only run 8 samples at a time, but we have 9 treatments. What do we do then?
You can still counterbalance treatments across incomplete batches using incomplete block designs. The idea is that you mix and match treatments within batches so that across all batches, each treatment appears with each other treatment an equal number of times.
That sounds much more complicated, and the number of possible combinations of treatments could get pretty large for that to work.
That's true. We would want to talk to a statistician to create the most balanced batching possible, and there are functions in common statistical software to help with that.
Okay. Well, given that we are supposed to start sample collection on Monday, I will plan on randomly selecting across treatments for each sample collection day. But I will be sure to revisit the incomplete block concept for sample analysis.
Sounds good. I will put you in touch with our statistician today.